Fecon Bullhawk is equipped with a variable displacement hydraulic motor, which is sometimes referred to as a two-speed motor. This motor is a key component in the performance and efficiency of the Fecon Bullhawk. However, it is dependent on the shift pressure adjustment. If this shift pressure adjustment is not done properly, poor performance will be experienced. Earlier in the video, we talked about setting your rotor speed. There, we were focused on our minimum displacement set screw. This set screw changes our swash plate angle within the motor. So our flow coming in, we can change our adjustment screw, which changes our swash plate angle, to affect our output of our motor itself. There, in our test, we were concerned with our rotor speed. We had a specific rotor RPM that we were trying to hit, and we can do that by our minimum displacement, right here on top of the motor. We also have the ability on this motor to change our shift pressure. That adjustment is found at the bottom of the motor, located here in our maximum displacement cap. Later in this video, we'll show how to do that. But really there, we're adjusting the pressure at which it takes to shift this motor from min displacement to max displacement. These two displacements working together is the most efficient that this motor can be. On your job site, when you're first starting into your cut, we are in min displacement. We're in a high RPM range, low torque. As we start into the material, that load goes up, pressure goes up, and starts to build. Once we hit that shift point, that shift pressure, whatever it may be, then the motor will shift into maximum displacement. There we gain high torque. Our rotor speed goes down at low speed, but we pick up high torque, so we get through the cut more efficiently. This same principle is found in the transmission on your vehicle. Say if you have an automatic transmission, as you go down the road and you see the load pick up, say a hill or whatever that you may encounter, that transmission operates off of pressure. It'll downshift based on the load, based on that pressure, and to make it up the hill most effectively, it'll downshift to accommodate that load. And once you get up the hill, the load dissipates, then you'll upshift again. Now, say if you had the ability to shift, say a manual transmission in your vehicle, and you saw the hill approaching the load go up, but you did not downshift, well, you would suffer momentum trying to get up that hill. You would not get up that hill the most efficient that you could. Same thing as if you shifted too early. You saw the hill, but you shifted too early, then you would suffer also. RPM and load of the engine would increase, and you would not be as efficient as you could be getting up that hill. The same thing would happen in our motor here, in our Fecon Bullhawk. If we shift too early, we're not getting through the cut as effectively as what we should. Same thing is if we shift too late, we stay in that minimum displacement at a high speed too long. In the remaining part of this video, we will discuss how to find your shift pressure and adjust it.
Here with the protection block on the bench, you can see the spike relief valve here on the left without the cap. This can be adjusted for shift pressure. We can lower the whole machine pressure by using this valve. This adjustment can be done at low flow. High flow is not necessary. All we need to see is pressure. Once the adjustment has been set, reset this all the way in and back out a half a turn. Over here on the other side, which will be positioned in the back of the head, is a GH port. It's got a test board already installed. Remove the cap and install your gauge. For the motor shift adjustment, begin by blocking the rotor and installing a 10,000 pound gauge on GH port. The spike relief will be adjusted to the shift pressure. Locate the spike relief valve on the hydraulic block. Adjust the spike relief to the shift pressure for our example, which is 2590 psi, which we are taking 60% of your stall pressure and coming up with our shift pressure from that. Once adjusted, move to the drive motor. Locate the M port on the motor. This will be opposite of the G port, which has a test fitting already installed. Here on the bench you can see the removal of the M1 port plug and the installation of a test port, which is also included in the startup kit available through Fecon. Once the test port has been installed, you can see how the gauge will hook up on the motor by moving the shift pressure adjustment screw located on the bottom of the motor. You can see the gauge moving here, showing the actual shift pressure. The rotor is stalled during this condition. This shows that the motor has been set to the predetermined pressure adjustment. Here's a motor getting ready to be installed on a Bullhog. You can see the shift pressure screw located in the maximum displacement cap, which will be on the bottom of the motor once it is installed. There possibly could be a cap installed on this shift pressure adjustment screw. But here is the removal of that and the adjustment. There is a lock nut and then the adjustment screw itself. Once the adjustment on the motor has been completed and your shift pressure is correct, reset your spike relief valve on the protection manifold to tractor factory spec. This concludes the installation of the Bullhog. If you have any questions, please contact Fecon.